CITS sections 2-4 is on quadratic functions. Now we cover a lot of material in here. If you remember back in Algebra 2, quadratic functions were covered in Chapter 4. And Chapter 4 was a 10-section chapter. It took the better part of 3 weeks, almost 4. We cover pretty much everything in Chapter 4 in this one section. So quite a bit of review. Hopefully you remember a good portion of it. And by doing some of the work, hopefully it'll bring the rest of it back. So we start out quadratic functions. Now we know by now the graph of quadratic functions are called parabolas. Okay, they always either open up, open down. Now they can open to the sides. We're not going to worry about that right now. That's when you switch x and y around. We're just worrying about the ones that open up and down. Okay. Now we call a standard form of a quadratic f of x equals ax squared plus bx plus c. That's the way it's always been called. Our textbook we're using right now calls a standard form what we used to call graphing form. Okay, graphing form is in terms of solving it by completing the square and getting y equals a times x minus h squared plus k. Okay, so just a little bit of terminology difference. I don't care if you flip it back and forth. Standard form, graphing form, this book calls this one standard form. Okay, so that might be just a little bit confusing. Now, when we graph our parabola, we get a few things out of it. We get our vertex, which is the point h and k, okay, out of our graphing form. Notice that h is always the opposite here because it's in the brackets. K is the same. Our axis of symmetry, being these parabolas are always symmetric. They look exactly the same, right side and left side, from this axis of symmetry. Our axis of symmetry is always x equals whatever the h value of that vertex is. Remember, the axis of symmetry is always given as the equation of a line. Make sure that you do that. Okay, now, so in an equation, y equals ax squared plus bx plus c. We have two ways of getting this into our standard form, okay, from this form to our standard or graphing form. We can use completing the square, which we've already done just a little bit of, but we're going to do a lot more in this assignment. Okay, we can find it by completing the square, or we can do a different method. In this equation, the vertex is always followed by these two expressions. So, excuse me, the vertex is minus b over 2a, remembering this is a, b, and c. So I take the opposite of the linear over twice the quadratic, and the constant in front. Then I plug that back in to solve it out, and I get the y value. Now, if you're just looking for the vertex or trying to find certain things from it, that's by far a faster way. Okay, if you're trying to complete the square or put it in graphing form, it's kind of a wash either way. Okay, but in some things, like when we're going to graph or find the equations of circles, we know we kind of need to have the complete the square. So that's why it's still there. Now, to find the x-intercepts, which again are called roots, zeros, and solutions, we set the equation equal to 0. We know the y-intercept of any general expression is always going to be c when it's all multiplied out. The maximum, it's a maximum if a, the value of a is negative. In other words, if it's opening down, we're going to have a highest point there. That's going to be called your maximum. And I give you some general instructions for domain and range. Same thing with a minimum. If a is positive, it's going to open up. So you're going to have a lowest point on that parabola. And the domain, notice the domain is always negative infinity to positive infinity. Here if it's opening down, your range is going to be from negative infinity up to that maximum point. If it's opening up, it's going to be starting at that minimum point and going to infinity. Now, when I started to work some of these problems, I kind of screwed up and wrote on here, so I'll start that one over again. Now, we want to put this, the directions of the book want us to put this in standard form, they say, we call it graphing form, by completing the square. And then graph it and give the vertex and the axis of symmetry. Okay, so here we go. To complete the square, first thing I do is I separate the constant. Okay, I then find my add-on term. I want to make this into a perfect square. This add-on term is found by b over 2 squared. So it's 49 fourths. I'm going to add 49/4 inside the bracket. I then, being it's on the same side of the equal sign, have to subtract it out here. Now remember, this term out in front is a 1. So the value of this 49/4, I actually have to take 1 times 49/4 and do the opposite out here. I can then factor. This turns into x. Always use the middle sign, whatever b over 2 was. And then I've got the 2 minus 49/4, which is going to be 8/4, so minus 41/4. Okay, so now we have it in graphing form. Okay, once we have that, we know the vertex. The vertex is always the opposite of what's in the brackets. The same as what's outside. Now I'm going to answer a couple of questions. Is this going to be a maximum or a minimum? This graph is opening up, so therefore it's going to be a minimum, and that minimum is going to be equal to that value. Okay, the y value of the vertex. We have an axis of symmetry. Axis of symmetry is always equal to the x value of the vertex. And then they want the graph of it. Okay, we'll give a quick sketch for the graph. -7/2, -41/4. -7/2 is about -3.5, so about here. That's where your axis of symmetry goes in. -41/4 is 10 1/4. I'm going to run out of room, so I'm just going to put a dot down here on the axis. Label that vertex. Now, in general, when we did this, if we're going to finish it out, we would find the x-intercepts. We're not going to do that on this one problem. We're just going to give a general graph, because that's all they really wanted. Okay? But we can find the vertex, max or min, axis of symmetry. Let's do this now, the domain. Domain is all real numbers on all parabolas, so -infinity to +infinity. The range, as it's going up, I come up until I hit that point. And that's my starting point, which is -41/4. It keeps going up forever. That goes to infinity. That's open, and that's closed. Okay, so kind of a quick review of graphing parabolas and working with them a little bit. Got a few more examples here of completing the square. Number 14. 14 wants us to do the same basic thing. Oh wait, I just did number 14. Must put it on a different sheet of paper. Okay, so I got more room to do 18. 18 wants us to do the same basic thing as we did for 14. So we're going to walk through it here. I'm going to complete the square here. So f of x, the first thing I do is I separate the 5 to the side. Inside the bracket, this constant in front of my quadratic term has to be a +1. So I have to factor out a -2 out of this to make that an x squared plus 2x. I now can find my add-on term. My add-on term is going to be b over 2 squared, which is going to be 1. So f of x equals -2 times x squared plus 2x plus 1 plus 5. Now, it's very important. I added 1 inside. The actual value of 1 is -2 times 1. So the value of this term is -2. I have to put the opposite out here, because I have just added, excuse me, I just added -2 here. I have to balance it out with the equation, with the equal sign. So I put a +2 out. I can now factor -2 times x plus 1 squared. It's always a b over 2. Plus 7. I can now answer all kinds of questions. I know the vertex is the opposite of what's inside, the same as what's outside, -1, 7. I know it's opening down. So if I look at this general graph, -1, 7. I'm up there. I know it's opening down. So I know the axis of symmetry. is x equals -1. I can put that in. I know that it's going to be a maximum, and the maximum is always the y value. Has a maximum value at 7. I know the domain is always -infinity to +infinity. And I know the range. Now this one's opening down, so I hit these arrows first. So it starts at -infinity, and it stops at the highest point, which is 7. Now the only thing we haven't found here is the zeros of the function. And we could use the zeros by doing the quadratic formula. I could take this, complete the square, set this equal to 0, and solve it out. But I'm not going to worry about that right now. Again, that's something we're going to do a little bit later on. Okay, so there's what I'm looking for. Oops, I want that part too. And just a general graph. I always label that x equals -1. Always label your vertex. -1, 7. And we're good to go. Now, they want us to change in 22 and 28 to use the vertex function. Okay, so all they want out of numbers 22 and 28 is they want to find the function in standard form, or in our graphing form again, and give the vertex of it. So, here we go. I know that this function, right now, is going to be, because the constant out here is 1, it's going to be 1 x minus h squared plus k. I just need to find h and k. Well, h is equal to minus b over 2a. b here is 0. So h is 0. K is equal to f of minus b over 2a. I plug the 0 in, which is f of 0, and I get -4. And that one's done. So I know my vertex is 0, -4. It's opening up, so I know it's a minimum at -4. Axis of symmetry, x equals 0. Domain is -infinity to +infinity. And being it's opening up, the range starts at the minimum and goes to infinity. Okay, 28, a little bit different. We're going to do that one also. So f of x now, I'm going to set it up in a general form, equals -5 times x minus h squared, and then plus k. So I need to find my h. Again, h is minus b over 2a. Opposite of b is 6 over 2 times -5. 6 -10ths is what, 3/5? Okay, and that'd be negative. So now that's going to be the opposite in here. It's going to be a positive 3/5. K is going to be the function evaluated at -3/5, which is -5 times -3/5 squared minus 6 times -3/5 plus 3. Solve that all out, and I get 24/5. And that goes there. So notice a little bit quicker, I think. So now I know my vertex is -3/5 and 24/5. I know my axis of symmetry is x equals -3/5. I know it's opening down, so it's going to be a maximum at 24/5. I know the domain is always -infinity to +infinity. And I know the range, since it's opening down, is going to start at -infinity and stop at the maximum of 24/5. Okay? Nothing to it, right? Let's see if we can get through these. They want the real zeros and the x-intercepts in number 36. To find these, I'm going to set it equal to 0. This one's a pretty easy one to factor. I'll let you go through the factoring form here. Ends up factoring as x minus 2 and 2x minus 5. Set each of those equal to 0. And I find the real zeros. Now when they say real zeros, they just mean not imaginary. Okay? And now, so there's the real zeros. They also want the x-intercepts. Notice they phrase it differently. That means that they want the actual coordinates. Oops, 0. So there's the real zeros and the x-intercepts. Okay, for 42, they want the maximum, min, and the domain and range. Well, we just did a bunch of these, so let's rock through it quick. To find the max or the min, that's the y value of the vertex. So I have to find h, which is minus b over 2a, which is negative 1 over 2 times 3, which is negative 1/6. I have to find k, which is f of minus b over 2a, which is f of negative 1/6. If I plug that in, I end up with negative 13/12. So therefore my vertex is negative 1/6 and negative 13/12. Now, it's opening up because that's positive. So therefore it's going to be a minimum at negative 13/12. My domain is always negative infinity to positive infinity. My range, being it's a minimum, I hit that first and then go up. It's negative 13/12 to infinity. Okay, so that's what they wanted there. Excuse me. Now, last one. The sum of the length L and the width W of a rectangular area is 240. They want to write W as a function of L. So what they have here, they got a rectangular area with a length L and W, okay, and they say the sum of the length, and this means that both of these are added together. So I'm not going to put an L and a W there, so it's asked a little bit different in this question. The total length L and the total width W, so the sum of those is L plus W equals 240. They want to write W as a function of L. Okay, so I'm going to write W as a function of L. So W equals 240 minus L. That's W as a function of L. So if I know L, I can find W. Write the area as a function of L. Well, the area equals length times width, right? Well, if they want it as a function of L, they only want L's in it. Okay, so therefore, the area equals the length. And now W, instead of W, I've got 240 minus L. So therefore, the area is 240L minus L squared. Now, they want to find the dimensions that produce the greatest area. Well, the greatest area is nothing more than either a maximum or a minimum. So all I have is I have this equation, and I want to find the dimensions or the L value that gives me the greatest area. Well, L has to equal to minus B over 2A. There's B, negative 240, over 2 times negative 1 is 120. So L is 120. I plug it back in up here, and I find out that W is 120. So therefore, the dimensions are 120 by 120. Okay, I'm running out of time on the clock here, so that's all I've got for section 2-4. Let me know when you have questions.